Okay, well, I guess we're going to get started. Welcome everyone to the special seminar with Myles Allen. Really grateful to have you here today, Myles. He's got a really amazing resume, which I'm actually going to talk to you about, but I met Myles, I think COP20 is when Tim Dixon introduced you to me for the first time.
That's right.
And we've kind of said hi in the halls and then got the chance to work together in Glasgow and ever since. So I'm really grateful for you being here. Thank you for being here. So Myles is a professor of Geosystem Sciences in the Environmental Change Institute at the School of Geography and the Environment and the Department of Physics at the University of Oxford, and he's the director of Oxford Net Zero Initiative. He's described by the BBC as the physicist behind net zero. And he's been studying how human activities and natural drivers contribute to changes in global climate and weather ever since the 1990s. And in 2005, Myles first proposed the concept of global carbon budget that peak warming is largely determined by the total amount of carbon dioxide we release into the atmosphere, not the rate of emissions or the atmospheric concentration in any given year. He's long argued that fossil fuel producers should be central to the solution to climate change rather than just part of the problem, which calls for policy innovation. And Myles has a TED Talk on this that I highly recommend. It's a brilliant TED Talk. So he's been awarded the Appleton Medal and Prize for the Institute of Physics, and in 2022, a Commander of the British Empire.
You don't need to mention. Don't mention that in Texas.
Yeah, for services to climate change prediction. So thank you so much. Let's give him a warm welcome. Thank you, Myles.
Thank you. Yes, no, we do go into slightly ridiculous titles in the UK. Anyway, but it's great to be here. Great. Thank you very much, Catherine, for the invitation. And thank you very much, everybody who came and talked to me this morning, because I've had a really fascinating morning, and it's been great to see the breadth and diversity of work that's going on here. But I'm particularly excited to give this talk in Texas, because I'm convinced that Texas is perhaps one of the, so it's either Texas or Norway would be my guess as to which is going to be the first jurisdiction in the world to achieve geological net zero, which is how ultimately the world will stop global warming. Again, my punchline's already been spoiled slightly from you seeing the slides, but to misquote, or as Winston Churchill is purported to have said about Americans, is they always do the right thing, having exhausted all the alternatives. And so I feel about this particular approach to dealing with climate change, it is how we will ultimately stop global warming after we've exhausted all the alternatives. At the moment, the sort of approach to dealing with climate change that I'm going to be talking to you about is very, very different from most ways in which governments and academics and everybody else, certainly civil society, frames the problem. Let's get back to just some basics. We know what it takes to halt global warming. This is the statement in the IPCC's 1.5 degrees report, which I was heavily involved in. And whenever you see these rather sort of tortured sentences in IPCC reports, you know that some people spent a whole night negotiating the wording, and that's why it's sort of, it was originally stop global warming, but that was too much for some countries, so we ended up with halt global warming, and there are things like that. But the sort of jargon in here, human-induced CO2 emissions, what we mean by that, and net non-CO2 radiative forcing just basically means other emissions, mostly methane. I'm going to be focused on CO2 though, because we require net zero CO2 emissions and declining methane emissions to achieve the Paris Agreement goals of stopping global warming. That reduction in methane emissions would reduce peak warming by a couple of tenths of a degree, which of course is important, it's valuable. But just to put this in context, that reduction in carbon dioxide emissions would reduce the rate of global warming by 0.2 of a degree per decade. So it's really important, particularly as the oil and gas industry is talking a lot about methane at the moment and how they're going to address their methane emissions. And I was hearing that apparently in the Permian Basin, there's still some methane intensities of 10% or so, which is pretty desperate. So clearly that's got to be cleaned up. But at the end of the day, this is a carbon dioxide problem. This talk is going to be about carbon dioxide. Where are we at? 1.25 degrees Celsius. I'm sorry, I use Celsius all the time. And we're warming at 1/4 degree per decade. So it's nice round numbers. And we know, therefore, what it takes to meet Paris Agreement goals. Again, it's simply your driving test. You know, if it's 1 second before you get to the junction, you've got 2 seconds to stop, only if you start braking immediately. If it's 10 years before you get to 1.5 degrees, you've got 20 years to stop the warming. So that's why we know to meet the Paris Agreement goals of well below 2 degrees, pursuing efforts to 1.5 degrees, we've got to stop global warming sometime around mid-century. I think it's really important, actually. One of the conversations I was having this morning was about how many people feel it's too late. And there's a lot of the sort of narrative around 1.5 in particular is focused on the fact that, well, we've missed 1.5, so it's, you know, we should give up. I mean, there's no. We need to stop global warming as soon as possible. If we manage to stop global warming around mid-century, we will limit it to pretty close to 1.5. That would be a huge result compared to the alternative. It might not be enough to limit it to exactly 1.5, but at the end of the day, temperatures fluctuate by 1/10 of a degree anyway from decade to decade. So I think getting too hung up on that is a mistake at this point. And, you know, again, just to remind you, of course, the Paris Agreement did not actually say we were going to limit warming to 1.5. It was pursue efforts to limit warming to 1.5. And the real commitment is to keep it well below 2. And that we definitely can do. If we can stop the warming before 2070, it'll be, and if we start reducing emissions now, stop the warming well below before 2070, we've got a very good chance of keeping it below 2 degrees. But the problem, of course, we know what we need to do. We're not doing it. CO2 production continues to rise. That's global fossil fuel emissions. And notice that this doesn't go to 0. If I showed you what a 1.5 degree trajectory looks like, it's that. So notice the COVID notch there. Basically, to limit warming to 1.5 degrees, we just need to keep going in a straight line, following down the COVID reduction. So you can imagine how disruptive that would be for the global economy. And, you know, we are seeing, in the meantime, oil and gas reserves are being maintained. The oil and gas industry is keeping up its reserves, and this remains a sort of highly contentious topic. I'll be coming back to this. So in the UK, it's becoming highly political, whether licensing of new oil and gas extraction in a very unhelpful way. A really interesting statistic that I came across recently was the valuation of companies in different sectors. And despite the fact, well, you know, perhaps because of the fact they're making such huge profits, oil and gas production is, you know, in terms of price earnings ratios of these companies, strangely undervalued. The valuation investors place on oil and gas companies is much less than would make sense given the amount of money they're making. You know, you compare an oil and gas production or refining company with, you know, a home improvement company, you know, B&Q or what is it, Home Depot. So the home improvement company is much more valuable relative to its profits, which is it's interesting. Why is the market valuing the oil and gas industry in this way? And, you know, a question to ask ourselves is whether this is part of the reason, as it were. Am I part of the reason? I'm not sure that I would flatter myself with that, but I mean, back in 2009, we arrived at this conclusion that in order to stop warming, it was the total amount of carbon dioxide we dump in the atmosphere that determines what temperature we get to, and that therefore, in order to stop global warming, we need to reduce global carbon dioxide emissions to net zero. And you'll notice in this schematic here, we've got 3 emission profiles. They all have the same integral under the curve. So the same total amount of carbon dioxide is dumped in the atmosphere. They all end up at the same temperature, and the differences between them are tiny compared to the uncertainty in the response. So it's not the rate at which we put carbon dioxide into the atmosphere, it's the total amount, which means, of course, that the likes of Jaron Rystad of Rystad Energy, so certainly no environmental NGO, is saying even with these mitigation measures, if global warming is to be successfully limited to 1.6 degrees, I'm not quite sure why he said 1.6 here, only half of the world's recoverable reserves would be required. And the question is, are investors in the oil and gas industry looking at statements like that and saying, is there something wrong with this industry, that at some point we're suddenly going to end up with a whole lot of stranded oil and gas fields, and that they're reluctant to invest in this industry because they think there's something hanging over it. There's this policy risk hanging over it. And of course, you know, there are people out there. I mean, this is not Jared Rystad. This, of course, is the people who are campaigning at COP28 and before to say, you know, we've got to phase out fossil fuels. We've got to keep the carbon in the ground. The difficulty is that if you actually look at the scenarios that meet the goals of the Paris Climate Agreement that limit warming to 1.5 degrees, this is what happens to global fossil fuel energy use, primary energy supply from fossil fuels in those scenarios. Now, it's a big spaghetti diagram, okay? They're all over the place, but the heavy line shows the median, so 50% above, 50% below that heavy line. And you can see, well, first of all, in none of the scenarios do we actually get to phasing out fossil fuels entirely, even by 2100. And in the vast majority, we're still using fossil fuels pretty extensively after mid-century. And remember that stopping distance analogy, we've stopped. I want to use my, yes, I can. You know, we've stopped climate change by 2060 in these scenarios. And yet we're still, in the vast majority of these scenarios, we're still using fossil fuels at a very extensive level. Not as much as we're using at the moment. A couple of rather odd scenarios where we seem to keep going. I'm not quite sure what happens in those. These are models of the world economy that are used to generate these things, and they're full of loads of assumptions that are all contestable. But they give you an idea of what is feasible. And it suggests that, you know, as Sultan Al-Jaber pointed out at COP, you know, there is no science out there, or he was corrected himself, there is no scenario out there that says the phase out of fossil fuels is what's going to achieve 1.5 degrees. This, of course, was picked up on rather sloppily, in my view, by The Guardian, who said COP president says there's no science behind demands for phase out of fossil fuels. If you look carefully at what he said, that wasn't what he said. He was actually quite careful to say it was no scenario. And what he said was absolutely accurate. And rather depressingly, everybody at COP piled onto him to say how he was, you know, back in the Stone Age and not understanding climate science. No, he was quite correct. Yeah, if you follow COP on Twitter, I was one of the few people who pointed this out at the time, and my comments then went completely viral. And anyway, it all went horribly wrong. But such is Twitter for you. It is depressing that this fossil phase out became lots of people were telling me at COP, yeah, we know about those scenarios, but the message has to be fossil phase out. And it's like, what? I mean, the point is, you know, we're scientists. We're not about being on message. We're about telling people what the evidence is telling us and what our models are showing and so on. And I do think there's a real problem in the scientists who are most engaged with the policy realm. It's difficult to keep just to the science. You get sort of dragged into being helpful. And I think we need to be careful about sort of selectively sending our messages to support particular positions. Because if we look in particular at different constituents behind this continued fossil fuel use, this is global gas production in those remember, all of these scenarios meet the goals of the Paris Climate Agreement. They limit warming to 1.5 degrees. And at the moment, according to BP, we have about 50 years of gas reserves at current rates of production globally. So that's what 50 years of reserves look like if you just assume a linear decline. So, looking at that figure, it's not at all obvious that half, what Reichstad said was that half the world's oil and gas reserves would have to stay underground. Well, that's not obvious from this figure whatsoever. People get very upset when I point this out, but this is what the numbers say. So you need to, come up with a reason for rejecting these numbers, because they are the best evidence we have available. Oil, perhaps you could argue that for oil, we have too many, as it were, too much oil reserves, and there's sort of, because in these scenarios we do decarbonize transport very rapidly. There may not therefore be the long-term demand for oil that's consistent with current reserves. But there's plenty of scenarios there in which we do continue using oil later on in the century. Of course, the one which is definitely stranded is coal. Coal reserves are hundreds of years of production at the current rates, and we just really have to stop using coal. But there's many reasons to stop using coal, not just the climate one. So I'm not going to pretend to you that it's all fine for every aspect of the fossil fuel industry. But I do think we need to be careful about the sort of phase out narrative applied to all fossil fuels, because yes, we need to phase out coal, and although the COP couldn't quite bring itself to say phase out coal, they said phase out of unabated coal, but at least the fact that coal needs to move faster has been acknowledged. But the situation on oil and gas is that we need to fix it before we phase it out. And that's what I want to talk about today. We're seeing, this is starting to get very political. So in the UK, Rishi Sunak has green-lighted new North Sea licensing, claiming, and the argument they made for really encouraging new licenses of production of oil and gas in the North Sea was that our oil and gas is greener than the stuff we import. Apparently UK production is greener than LNG imported from Texas. I don't know if this is true, but I mean, this is the claim. So he uses that argument to justify new oil and gas licenses. This has become political because the Labour Party, our opposition in the UK, is committed to not renewing, to banning all new extraction or all new licensing of fossil fuels in the North Sea. And this is therefore, for the first time, climate has now become a political issue in the UK. And the Conservative Party is using it to hit the Labour Party. It probably won't be enough because they've managed to hit themselves so much that it doesn't really matter what they do to the Labour Party, but who knows? We do have an election coming up and we'll see what happens. Just in the past couple of days, we've got news that your administration here has paused permitting of new LNG exports. And this has triggered a lot of discussion. And it's quite a nuanced conversation, because one of the problems with pause with blocking, it's a pause, it's not a block, but if it turns into a block on LNG exports, the counterfactual of what happens, and I was reading actually as a professor in the University of Austin has been commenting on this in the press recently, the counterfactual of what do countries use instead of LNG imported from the US is really important to determine whether or not that actually has a beneficial impact on global climate. So these are both the Labour Party's position saying no new oil and gas extraction in the North Sea, and the Biden administration's position saying, possibly saying no new LNG export infrastructure in the US. They're quite vulnerable decisions because they don't obviously deliver on the climate objective. They sound good to environmental activists, but are they actually coherent policies? And if you have an incoherent policy, it's much more vulnerable, obviously, to the other side to criticize it. These are the questions we'd like to sort of address here. We've got this interesting sort of undervaluation problem of oil and gas companies, and in particular, in Europe, this is probably more relevant in Europe, but our European oil and gas companies are talking a lot about how they're diversifying themselves into general energy companies, and they're investing heavily in biofuels and nature-based solutions and so on. But it doesn't seem to be working. The market doesn't seem to be impressed at all. And in fact, in many ways, the market is rewarding US oil and gas companies who have a very clear climate strategy, which is like, whatever. I mean, and that seems to be, the market seems to be quite comfortable with a very clear strategy, even though the strategy is not really a strategy, but at least it's very clear what it is. So the sort of confusion over what the oil and gas industry is going to do is actually starting to perhaps potentially cost the industry itself. We also have confusion over licensing, government's involvement in licensing of new infrastructure, because these arguments about is it needed, is it helping, is banning it going to help, or just move production to different parts of the world. So, question to ask: do oil and gas producers and exporting countries or exporting states, like the state of Texas, need a more transparent and comprehensible approach to net zero? And that's what I want to talk to you about. Just to get back to basics, this is what it takes to stop global warming. So these are those scenarios that I showed you earlier, or that meet the goals of the Paris Climate Agreement. I've got rid of the spaghetti by just showing you the median pathway and the 25 to 75th range. So it's an indication of the range. And in red, it's carbon dioxide production from fossil fuels in industry. So as you can see, that goes down. We burn less by replacing production with solar, and this is what everybody knows about. This is all happening. But it doesn't go remotely close to zero. It goes down by maybe 75%. And then we achieve net zero by storing a great deal more. And the blue line there is the carbon dioxide we store back underground. So this is currently 40 million tons of carbon dioxide per year re-injected back underground. And it goes up to, somewhere between 10 and 20 billion tons of carbon dioxide per year by mid-century. And the scale of that transition, this multi-hundred-fold increase, so going from 40 million to over 10 billion, there's a factor of 250 increase in the rate at which we inject carbon dioxide back into the Earth's surface, is overwhelmingly the biggest challenge in dealing with the climate issue. And you should be honored that you have people like Catherine here working on solving that challenge, but unfortunately there's only one of her, or at least not very many of her. And that's a real problem we've got at the moment, because if we look at, sorry, I digress, on something else, but we'll come back to that. But the scale of that challenge is so huge and so badly underestimated and completely downplayed by the fossil phase-out argument, which is, oh, we don't need to store CO2 because we're just going to stop using fossil fuels entirely. Well, the answer is we're not, and therefore neglecting our obligation to drive up carbon dioxide storage is absolutely essential. There's a green line here, which I will want to talk about, because it's become, in my view, a bit of a distraction in the big picture here, but I'm going to digress a little bit to address it. And this is the contribution from reducing deforestation and the transition to nature-based solutions to remove carbon dioxide from the atmosphere. This is massive. This was massively talked about at COP28. It's always talked about heavily at COPs. Everybody loves to talk about it. Planting trees, restoring mangroves, restoring coastal ecosystems to absorb carbon, and obviously reducing deforestation. They're all great things to do, and they do provide some contribution to achieving net zero. But do look at the lines here. That green line is quite close to the zero line. If it wasn't there, it wouldn't really change the big picture very much. And so it is important to keep that contribution from nature-based solutions into perspective, there's also a real problem that we are facing at the moment, which is that this is not the only carbon that's being absorbed by nature over the next few decades, because nature, the biosphere and oceans are absorbing carbon at a massive rate already just because of past emissions, because we've driven up carbon dioxide concentrations in the atmosphere, the biosphere is responding, the oceans are responding and taking up CO2. So actually distinguishing between carbon dioxide we deliberately put back into the biosphere and carbon dioxide that's being taken up by the biosphere anyway, just because of the way it's responding to past and present climate change, is virtually impossible. And because of this, it's a small contribution and also a source of considerable confusion, and actually is really holding back focusing on what we really need to do at the moment. I was going to show you an equation at this. Well, I'm going to show you an equation because, you know, hey, I do come from a physics background. So it's an important equation because it tells you what drives carbon dioxide induced warming. And it, by the way, for those of you who don't do climate modeling, it's quite a useful equation because pretty much all the really complicated climate models, when it comes down to their behavior in terms of global temperature, this equation is pretty much good enough. Now, I notice people who do climate modeling are looking at me suspiciously here, saying, am I sort of ridiculing our entire profession? Of course, all this tells you is the implications of emissions for global temperature. It doesn't tell you anything about the weather, it doesn't tell you anything about the oceans, it doesn't tell you anything about anything else, but it does tell you how emissions at the moment and in scenarios that meet the goals of the Paris Agreement relate to global temperature. So it's worth going through. That's the change in warming over a multi-decade period, change in global temperature. These are two contributions here. One from geological origin carbon dioxide and land use carbon dioxide from active land use change, so deforestation or deliberate reforestation, so active interventions in the biosphere. That's not the passive removal that happens because climate has changed anyway. And then over here, so people kind of know about this bit. You put more CO2 into the atmosphere, you multiply by a constant and the length of time you do it, and you end up with the warming. So that's the sort of cumulative impact of carbon dioxide emissions on climate that's been well known for a decade. Over here, I've written in this extra term here, those two rates, these are both have units per year. These are rates of adjustment, both the rate at which the world would warm if you were to freeze atmospheric CO2 concentrations. So if you were to stop concentrations from rising today, but not reduce them at all, just keep them steady, then the world would continue to warm, and it would continue to warm at a rate of roughly 0.3% per year, 3% per decade. That's that term. But if we reduce emissions all the way to zero, then there is the natural carbon cycle takes carbon dioxide back out of the atmosphere, reduces carbon dioxide concentration in the atmosphere just fast enough to balance this rate of warming. So we end up with these two rates which cancel. And you have this passive carbon dioxide removal by the biosphere and oceans, which is really important. It's equivalent to active removal of 10 billion tons of carbon dioxide per year by mid-century in a 1.5 to 2 degree scenario. So this is not a small term. I'm stressing they cancel, so they add up to zero, but neither is small. Yeah, the warming after the ongoing warming after CO2 stabilization would add up to about 0.5 degree per century if that's all we did. So we do need the biosphere to be taking this carbon out of the atmosphere. We also and we need to protect the biosphere in order for it to be doing that. But we can't regard that as part of this land use change emissions. If we muddle up this passive removal of carbon due to past emissions with our active removal by planting trees or restoring mangroves, then potentially we double count the same carbon removal. We take credit for carbon removal that's happening anyway and use it to offset our ongoing fossil fuel emissions. And if we do that, then we don't end up stopping global warming at all. And this is an issue because, you know, the great headline achievement of COP was that we were going to transition away from fossil fuels in energy systems so as to achieve net zero by 2050, in keeping with the science. And a few of us who were there while this was being discussed pointed out, and I know this was raised because I fed it into one delegation who said, yeah, they would take it forward. Doesn't net zero need to refer to something like net zero emissions or net zero something? And apparently, no, we're just going to achieve net zero. Okay, you know, okay. So I mean, obviously, you know, diplomacy is the art of the possible, and I think actually the full credit to the UAE presidency. It was a tremendous achievement. They got this language agreed by everybody. But one of the prices of that is you just have to have phrases in there that maybe don't make a whole lot of sense. So they're aiming to achieve net zero, but they won't say exactly what net zero was. And the difficulty is, if we look at flows of carbon into or out of the atmosphere under different scenarios, so the left here we have, here we are, left we have the present day, so lots of carbon being dumped into the atmosphere, quite a lot being removed by this passive response of the oceans, but not enough, so carbon dioxide concentrations are rising in the atmosphere. That's the situation we're in. If we were, if we were to reduce our emissions immediately by less than 50%, and sort of bump up nature-based solutions and so on, we could stop concentrations rising and on current accounting rules, claim we've achieved net zero. Of course, that wouldn't last very long because as soon as you stop concentrations rising, the biosphere and oceans, there's the light green and blue bars there, take up carbon less rapidly. So but they keep taking up carbon. And so even after a few decades, you could get to a situation you get a situation where you have a balance between ongoing fossil fuel use and uptake by the land and the oceans, which keeps concentration stable, but is not enough to actually stop global warming. And to stop global warming, you need to get to, you know, either panel D or E. In panel D, you've got some balance between fossil fuels and storage of carbon in the biosphere. So there's some balance in the red bar and the green bar, but that can't last very long because, you know, there's limits to how much we can rely on the biosphere to absorb ongoing fossil fuel emissions. So we've argued in this and other papers that the only durable net zero that would actually stop global warming for, you know, multiple decades is one in which you have a like-for-like balance between any continued generation of CO2 from burning of fossil fuels is balanced by geological disposal, so engineered capture and reinjection back underground. So that's why there's a balance in the red and the gray bar. And that if you're still producing emissions from food production from the biosphere, that's the brown bar, you're balancing that with your nature-based solution. So the idea that you can balance continued fossil fuel generation of CO2 with nature-based uptake indefinitely, I don't understand why it makes sense to anybody, because, you know, you've only got to stop and think about it. We can't turn rocks into trees forever. But there's huge enthusiasm for this because, of course, it is a much lower cost and quite attractive approach to addressing emissions at the moment. And the difficulty is that, you know, if you've got a good accountant, all four of those could count as net zero. And in fact, if you're just one player in the world, you're not the world as a whole, if you can find enough of this stuff to balance your emissions, you can claim to be net zero already. So if you want to, if there's graduates in the room want to have a profitable and immediate, highly profitable job, move into the carbon credits space and start advising companies on how they can make themselves look net zero. And, you know, you'll have a good life. Just a shame about the planet. Anyway, because the point is we are seeing how the biosphere is already responding to past emissions. You can see this is the same scene in Africa And you can see how the vegetation is transformed over the past century. And, you know, Bond and Midgley and Bond looked at this, modeled it, and established that that recovery of it's not really recovery, because this is actually the biosphere moving to a new unnatural state for that part of Africa, is because of the extra CO2 in the atmosphere. So this is happening. And it's happening all over the world. This shows you where, up until 2019, so before all the forest fires in Canada, although the little purple patches are where there have been forest fires over that period, we've got absorption of carbon dioxide by the biosphere. And if you just add this up, you know, Canada's forest sink over that 20-year period was about 1 billion tons of carbon dioxide per year. Canada's emissions, any Canadians in the room note, were about 750 million tons. So, and people in Canada have noticed this and say, wait a minute, we're net zero already. No, well, I mean, yes, on the accounting rules used by the UNFCCC, they kind of could be, okay? But that's a problem with the accounting rules. Because if we all declare that, you know, if we all take credit for that natural response to the biosphere, we won't stop global warming. And we're seeing this happening all over the place. In the build-up to COP, we heard about the Dubai-based investor, Blue Carbon, have just leased 10% of Liberia for carbon credits. So this is turning into huge business, which will be very, very difficult to unwind. You know, now both Blue Carbon, or Blue Carbon can probably afford to drop a few because, I mean, you know, they're probably quite rich, but Liberia's economy is now becoming dependent on this carbon credit market. And this is a real concern. So even though I'm saying it shouldn't be a problem, I'm digressing onto it because it is a real issue at the moment. And it's one I feel strongly about because, you know, when we published all these papers in 2009, it didn't occur to us that this response of the biosphere was anything other than natural. Of course, it's not entirely natural because it's happening because of our past emissions, but we called it the natural response to past emissions. We didn't call it greenhouse gas removal. But unfortunately, the United Nations rules allow countries to take credit for this if it takes place on so-called managed land. And suddenly lots of land is managed. And we're seeing adverts like this one from a major fossil fuel company saying you could drive carbon neutral by planting and restoring forests. So just to give you a sense of the scale of this issue, this is that green hashed curve there is the sort of unaccounted for carbon. And this is the ambiguous carbon at the moment. This is the carbon that in one set of accounting rules is regarded as a removal. And in the way we as the scientists treated the problem, we regarded it as a natural response to the biosphere. And if you look at this, it doesn't look like that big a deal. It's like a small fraction of the problem. And as we reduce emissions, it seems to get smaller. But the problem, of course, is that it's only part of what's being taken up by the land and oceans. So here it is over here, again, with the other removals that are going on in the land and the oceans. And, you know, Europe has just decided to include this in Europe's definition of climate neutrality. So despite having said for years that it would never do such a thing, other countries are waking up to this. No doubt Russia and Canada eventually will. And so, well, maybe Canada won't, I'm sure, well, whatever, I don't want to get too specific here. But you know, there's already talk about managed oceans. You know, blue carbon is a big theme. And if island states decide they want to take credit for the carbon being absorbed by the ocean around them, well, there's nothing in the rules to say they can't. But of course, if that happens, the net result is we'll achieve net zero, but we won't actually stop global warming, which was kind of the point. So these are the issues here. I mean, you know, everybody loves nature-based offsetting, but there's a scale problem that the green line was a bit close to the zero line. There's a permanence problem, and there's the additionality problem that how can you be sure that carbon you're putting into the biosphere is actually additional to what would have gone there anyway, particularly when we're going to be short of land for food production. So if you're devoting land to absorbing carbon, how can you be sure that that's not simply displacing land for food production to somewhere else? So to get back to basics, we need to stop fossil fuels from causing global warming. And that really means a balance between the red line and the blue line. This is what we call geological net zero, where you're putting carbon dioxide back into the Earth's crust at the same rate that you're taking it out and generating it from continued fossil fuel use and production of cement. So the red line and blue line are equal, and that's geological net zero. So basically, we need to get, over the next 20 or 30 years, we need to get from where we are now, which is 0.1% of carbon dioxide is put back underground. That's the 40 million tons per year. We need to get that up to 100%. So if we don't, that would mean a 1,000-fold increase in the rate of injection if we don't reduce fossil fuel production at all. Actually, you can see we do reduce it by around a factor of 3 or 4. So it's only a 250-fold increase in the rate at which we store. But we need a maybe 10, 20-fold increase in the rate of renewable energy generation over this period. We need a 250-fold increase in the rate of carbon dioxide storage. And I'm going to move on from that. And if we look at where the investment is going in different technologies for the transition right now, this is from Bloomberg New Energy Finance, you can see there's only 2 of these technologies are directly relevant to stopping fossil fuels themselves from causing global warming. That's hydrogen and CCS. So hydrogen is relevant if you're using hydrogen technology to decarbonize fossil fuels and use hydrogen as an energy vector. If it's blue hydrogen, that's all relevant to avoiding, to preventing fossil fuels from causing global warming. Of course, carbon capture and storage is central to. And can you see on the, well, you can't actually see on the graph where the hydrogen and CCS bars are. They're here, okay? You can't even see them. And it's 25% of the solution and much more than 25% of the cost, because this is the expensive 25%. And it's getting none of the investment. And nobody's talking about this. Indeed, Bloomberg New Energy Finance almost celebrated it by saying, yeah, CCS has been technology. It's not getting the investment. That's a great thing. It's the biggest problem we've got at the moment. And the reason is really straightforward. Again, this is from a Goldman Sachs report, but I mean, the basic point is fairly obvious. If you look at measures to reduce, this is one of these classic marginal abatement cost curves, the cost of reducing emissions. Okay, the more you reduce emissions, the more expensive it gets to reduce the next ton of emissions. And this shows you on the same graph, measures to increase CO2 storage in blue and measures to reduce the amount of CO2 we produce in red. And you can see that over a lot of, halfway at least, it's cheaper to avoid producing the CO2 than it is to store it. Yes, carbon capture is expensive. It's much cheaper. There's so much of our fossil fuel use is very inefficient. It's much cheaper to reduce our use than it is to store the CO2. But then you hit a wall. Then you get to applications like cement production, like aviation, where there is no alternative to using fossil fuels, and there won't be an alternative in time. So we end up with the cost of reducing emissions becomes the cost of actually banning activities. And that becomes very, very expensive indeed. So it's that final 25% where we absolutely counting on driving up our capacity for CO2 storage. So how do we pay for this? So right now, carbon dioxide disposal is either entirely paid for by taxpayers, which is the system here in the US pretty much with these 45Q credits, or at least the risk is borne by the taxpayers. So that's what, in the UK, we're doing it entirely with public subsidy. In the European Union, they're trying to build systems where there's at least a risk sharing between the private and public sector. But the public sector is completely on the hook on this. Neither of these mechanisms is particularly efficient at driving down the cost. And that's, I'm sure, a lot of the reasons why we've not seen the cost reductions we would have liked to have seen in CCS over the past 20 or 30 years. And they both involve a big and very uncertain drain on public finances. And I'm very concerned in the UK that climate policy is starting to become political, and if we are dependent on public subsidy to drive the whole carbon capture and storage industry, another government will get in and just say, no, I'm sorry, we want to spend that money on something else. So how can we, and also, again, I'm in Texas. Nobody likes public subsidies in Texas, do they? I mean, so how can we change the narrative around this so that carbon dioxide disposal can become something other than a sort of low margin, boring, subsidy driven public service? And here's a suggestion for you to sort of take away as to how it could be done. So this is our current situation. Blue shows you the flow of actual or embedded carbon dioxide through the economy. It comes in from an extractor or an importer. It's sold to an industrial refiner or a factory that produces goods, which are sold to consumers, and it all ends up in the atmosphere. Okay. Right now in Europe, so this is the point sources are have a emission trading system imposed on them. So the only people affected by climate policy really are the point sources. So they're unhappy. The consumers are confused because they can't quite see what the point of this climate policy is. The atmosphere is sweating. Over here, we have a geological storage operator who is sad and lonely because they have no business. I mean, there's no arrows pointing towards them. There's no business case for doing what they're doing. They've dug a hole, but there's no CO2 to put into it. The government's fast asleep, and the extractor importer is laughing all the way to the bank. So we introduced something called a carbon take-back obligation. This is a policy mechanism that requires the extractor importer to produce evidence that some carbon dioxide has been stored, some fraction of the carbon dioxide that will be generated by the fossil fuels that they bring into the economy. A small fraction to start with, 1%, a few percent. What then happens? Well, they obviously have to buy that from that carbon storage from the geological storage operator, who has to get the carbon dioxide from someone else. They probably buy it from the industrial point source, who is now intrigued because instead of carbon dioxide being a liability, carbon dioxide becomes valuable. Carbon dioxide becomes a resource. And it's worth capturing it because then you can sell it to generate these certificates. Consumers wouldn't notice because it's quite small still, this obligation. The atmosphere is still sweating. It hasn't made any difference to the flow of carbon dioxide into the atmosphere, but the geological storage operator is now happy because they have a business. The government has its nerd glasses on because it's learning how to do this. And of course, the extractor importer is very cross because they now have a cost which they didn't have before. But hey, they have broad shoulders. Okay, we scale up the stored fraction. We increase this fraction. The industrial point sources are now happy because they're being paid a lot for their CO2. Consumers are probably still confused. The atmosphere is feeling a little bit better because we've now got a new element has appeared in this, the direct air capture operator, because the geological storage operator has run out of CO2. They're having to recapture CO2 from the atmosphere in order to generate certificates fast enough to satisfy demand for these storage certificates. They're doing really well. And the government is still getting good at the job. And the extractor importer is maybe feeling a little bit better about things because they're starting to see how this actually could provide them with a sustainable future. Finally, we get to net zero. The industrial point source is happy because they're selling all their CO2 and not having to pay into the emission trading system. Consumers are happy because we stopped global warming. The atmosphere is breathing a sigh of relief. The geological storage operator is still making loads of money. The government is feeling awesome because it stopped global warming. And the extractor importer has saved the planet. There are other ways of doing it. Here's the emission trading system that we're counting on in Europe, where the government just requires the industrial point source to get rid of CO2. That makes the industrial point source very cross. The whole burden gets put onto them, and they head off to China. Nobody wins. The other option, which is kind of your model over here, is a tidal wave of government cash is thrown at geological storage operators, which means the government's cross because it's spending a lot of money, and consumers are cross because their taxes are being spent on very rich companies. And again, I don't think it's a sustainable model. We need to think about this because the economics are remarkably interesting. If you think about what it costs to dispose not of all of the carbon dioxide associated with the use of fossil fuels initially, we have to get there eventually, but initially, you start small, start at 1%, 10% in the 2030s, and 100% by 2050 is what we should be aiming for. The cost of that would be reflected in the cost of fossil fuels to the consumer is perfectly manageable. It's not, an immediate penalty that would put people off climate policy. And it would work. It would get us to net zero. It's a simple, single regulation that would get us all the way. And, if you just think about what it means, even in 2050, and this is 20 years away, 25 years away, we need to be in a situation where every ton of carbon dioxide generated by any continued fossil fuel use is being captured and put back underground. And by that stage, probably a lot of it would be having to be recaptured from the atmosphere and put back underground, because many of the applications we'd still be using fossil fuels for will be mobile, and we won't be able to capture the fossil fuel at source. It's 50 pence per litre of petrol. Okay, apologies for the unit here, but that's how that compares to UK fuel prices over the past 20 years or so. So, less than the gyrations in fuel prices we had during the Ukraine crisis, since the Ukraine crisis blew up, and also, more relevantly, less than the overall trend in fuel prices we've seen since 2004. And that's over a similar period. It's even more strikingly small compared to the fluctuations in natural gas prices we've seen in Europe over the past couple of years. And the point is, while nobody's liked these high prices, the world hasn't come to an end. Whereas, not to make sound too much like an environmentalist here, if we carry on putting the CO2 in the atmosphere, well, one day. Anyway, we need, just to sum up, we need net zero stuff. We think too much about this problem as we need net zero systems or we need net zero companies. No, we need net zero commodities. And we really only need 4 commodities to be made net zero: coal, oil, natural gas, and cement. If we stop those 4 commodities from causing global warming, we largely solve the problem. Yes, we need to stop deforestation. We need to do that anyway. Yes, we need a more sustainable food supply system. Yes, but we need that anyway, okay? These are the big ones. We've got to stop these products from causing global warming. And in each case, the cost of decarbonization would be less than wholesale price variations over the past 18 months. Just remember this. We didn't save the ozone layer by changing consumer attitudes to personal hygiene. We fixed the stuff in the can. We have to take the same approach to dealing with climate change. So this was this morning. So I was just thinking about how could this map onto the current situation the US is in, how Biden could really secure his place in history. Just imagine if he sat at in the Oval Office and said, look, the United States will be the first country in the world to stop fossil fuels from causing global warming. And we're going to do this by ensuring that 1 ton of carbon dioxide is safely and permanently disposed of for every ton generated by any remaining fossil fuel production and use by 2050. New licenses for any new infrastructure and extraction will require a credible disposal plan applying to all the CO2 associated with the project, 10% by 2035, 100% by 2050. And we're going to require all our trading partners to do the same. So come on, Europe, China, Australia, you've all got to step up. That would take less than 30 seconds, and it would completely transform the world. Because there's no way the European Union would be able to not go along with that approach. Everybody would kick up, everybody would complain, but at the end of the day, the logic is absolutely unassailable. Interestingly, most of the environmental justice movement would immediately attack it, which is really depressing. But it would solve the problem. Because we need to stop fossil fuels from causing global warming before the world stops using fossil fuels. And just to sum up with a punchline, quoting I quoted Sultan al-Jaber earlier. I'll quote an earlier gentleman, Sheikh Jamani from the Saudi oil minister in the 1970s, commented that the Stone Age didn't end because we ran out of stones. The oil age won't end because we ran out of oil. And we have to recognize and accept that global warming must end before we stop using fossil fuel? And I'm sure you've got some questions.
Thank you for that awesome presentation, as always. I love it. Okay, so questions, Dolores.
I haven't, no. I'm doing my best as an academic. And indeed, actually a couple of students of mine have actually now set up a little NGO, Carbon Balance. They're actually sort of campaigning for this, for essentially producer responsibility for the fossil fuel industry. This is what it is, extended producer responsibility is what we're talking about. But it's incredibly heavy going, mostly because nobody likes this. Fossil fuel industry doesn't like it, of course not. The environmental justice movement hates it because the idea of a responsible fossil fuel industry is just anathema to them. Governments don't seem to like it because, I don't know, they're sort of wedded to the way they're doing things. It's so hard. And because I think there's a lot of path dependence in where we're at. We're doing climate policy the way we're doing it. You know, if I give this talk to civil servants, it's like, yeah, that's really interesting, nice academic talk, but there's always a but. And then this is the reason why we're going to ignore you now. And this would be such a win for the Biden administration. But I fear their but will be, yeah, that's really interesting, but the EJ movement won't like it. And that might cost us votes.
Diagram, you've got government on one side and consumers on the other. Consumers are always confused. You know, in Texas, vast majority of consumers fill their tank with gas. A substantial portion of that gallon of gas is tax. So why isn't the link much more direct? I mean, why don't you can leave the consumer confused, but increase the tax. The government has the money to turn around and hand out this flood of cash, and Biden doesn't even have to be honest. No, I mean,
no, but I mean, if he was, why not?
No, but if he was honest, consumers would be mad that there's more tax. But in fact, the average Texas consumer has not a clue where the taxes on a gallon of gas go.
Yeah.
And so my view is keep the consumer confused. Send the money, increase the taxes. The price of oil, the price of a gallon of gas fluctuates a lot, as you have said. And then the government has the money and
so
problem solved.
This is where I'm going to sound like an old style Republican, a 1980s Republican. I don't want to trust the government with that money. Yeah. I don't, but I actually am quite serious about this because I come from the UK. I do not want to trust my government with any money that I can avoid trusting it with right now. I mean, we've had bad experiences with governments and money recently in the UK. So if you can do it with a regulation that simply requires the industry to fix the problem, so the government doesn't get involved at all, apart from just policing the regulation, I believe it's a much safer solution. As soon as the money is flowing through government coffers, certainly in the UK, and I suspect here as well, people could wake up and say, oh, there's all this money over here. Maybe we can divert it to my pet project, and it all gets a bit messed up. So I agree with you. I think the scope for, you could completely make this, you could make this policy completely. You could make this policy completely invisible to the consumer by reducing taxes at the same rate that you're driving up the obligation. The difficulty, of course, is one suspects that unscrupulous companies will be going on and on and on about the fact that, oh, this is how much your obligation is costing you, and it will have sort of special stickers in gas stations to emphasize this and so on. So, I mean, that sort of stuff will go on. On the other hand, unlike the green levies argument we've had in the UK, where this has become a big political hot potato, the difficulty with green levies is people couldn't quite see what they were doing. They were just, it was a tax, but it wasn't, how was it actually solving the problem? the advantage of this is it's like you're getting rid of the CO2. So it's very transparently addressing the global warming impact of your driving. So I'd like to think, maybe I'm naive, but I'd like to think that consumers would be, better able to wear that than just another tax.
If they know about it and they know the tax is increasing on them, they will.
Yeah, but it's consumers never like things becoming more expensive, but I think it's possible that they will resent it less if they can see a clearer link between the extra money they're spending and fixing the problem, and that it's not just being trousered by the government.
Thank you. That was a really great presentation. You boiled out so much information into a really direct communication. I have one over the time period. Why just 2100? My granddaughter might still be alive then. And what would be the year where if you extended that time period, it would be no more fossil fuel production? Would there be a year where you would have that?
That's a real interesting question. I mean, the scenarios we have are only run out to 2100. And as you can see, the lines are pretty flat in 2100. We have a sort of pretty stable economy, which is still using fossil fuels at that point. Now, at some point in the future, and indeed, Sultan Al-Jaber acknowledged this in the next sentence of that interview, at some point in the future, we will stop using fossil fuels. We very possibly will stop using fossil fuels even around 2100. I mean, it depends on the economics of the alternatives. But one thing I think is completely clear is we won't stop using fossil fuels by 2050. So to me, we won't, this is why Sultan Al-Jaber's statement was totally correct, we won't achieve Paris Agreement goals by stopping using fossil fuels. We may stop using fossil fuels as a result of having achieved Paris Agreement goals and then discovering that actually it doesn't make much sense to use fossil fuels for many things anymore, so we'll just stop using them entirely. But we've left it too late to achieve Paris goals by phasing out fossil fuels entirely. The other question is whether a future in which there's some residual fossil fuel use, 100% compensated for by carbon dioxide capture and storage underground, is that a terrible future? I mean, if you think about it, fossil fuels that don't cause global warming are not a bad energy source.
I wonder about the analogy between the carbon take back and the way that we handled water issues. In the 1950s and 60s, you could release poor quality water from your facility, whatever it was, onto the open water body, and it resulted in the same kind of hazard to the system that releasing carbon dioxide into the atmosphere does now. The way that that was solved was not as explicit. It wasn't just a take back. It said, but you can't do it.
Yeah.
You can't release it. So I kind of like that, but for the breadth, because it embraces options. You could decide. So the options for water is you could decide not to use water, so air cool or something else. You could decide to hold it, confine it, and use I don't know what the equivalent of CO2 is, or you could deep well inject. So you have these options instead of having to only one option. The industry had a lot of options but you just can't emit it. I wonder if that's the trend that might get embraced.
Yeah, I think if you had a regulation like this, you would unleash a lot of innovation in the industry. For example, would the industry choose to continue to sell hydrocarbons and take CO2 back from their customers or from the atmosphere, or would they sell hydrogen instead? Now, I don't know the answer to that question, but I don't think it should be up to me to decide that. I mean, that's the kind of question which is best sorted out by an industry that knows what it has to do, and yeah, the market, then they can sort it out. So yeah, I mean, I think having a clear rule like this, which then everybody can kind of work within, could unleash all sorts of innovation. Yeah.
Myles, thank you for your presentation. I was thinking, how do you consider the potential development of the carbon market in your whole conceptualization of this? Because if those four industries, those four sectors that you were looking at as a major have a clear price, a commodity in CO2 storage. It could solve the problem. You don't need all the, government, all the complexity of the system. I mean, with a clear market, with the CO2 as a commodity, and not only CO2 storage as a commodity, probably that could be a solution. I don't know if you consider that.
I do think about this a lot because in Europe, everybody believes in carbon pricing. It's sort of the mantra is if we had a carbon price, we solve the problem. But I want to go back. Sorry, I'm just being a bit. Here we go. I want to go back to this diagram. The way a carbon price works is it discovers the next, as the carbon price rises, it discovers the next cheapest way of reducing emissions. And, because of the different shapes of these curves, if you rely on a carbon price, you put off carbon dioxide storage until when you've run out of every other option. And only then do you start putting CO2 back underground. And then you try and put a lot of CO2 back underground because then it's your only option left. And the carbon price has got so high that you've got no option but to put the CO2 back underground. But this is exactly what we don't want to happen for the development of an industry like geological CO2 storage, where it takes decades to establish, well, I mean, with the kind of work that Catherine's doing here, maybe we can make this faster. But the point is to convince the public that CO2 stored in a saline aquifer is going to stay there for thousands of years. You've got to put it down there and measure it and prove that it's not leaking and all that sort of thing. So we need to be driving up the rate of storage gradually. We can't just leave it until the 2040s and then expect it all to happen overnight. And my fear is that if we rely on the carbon markets to do this, rather than regulation, that's what will happen. The nature of a market is it does everything at the last minute. It does the cheap stuff first. That's the way a market works. And that's very efficient. That's a good thing, that the markets should work that way. But they can go wrong when you have a situation like this, where we need that time. We need to spread out the development of the carbon storage industry over decades because of the nature of the industry. It's not something we can deploy quickly. So that's why I think it's got to be regulated. So I feel sorry, you've triggered this. I feel strongly that markets are not going to solve this problem. But many people I talk to disagree. So there we are.
Okay, and just one real quick, we're running out of time, but one real quick question on the chat. We have Tim Dixon on the chat asking, what about the Net Zero Industry Act? What about the EU? How are they thinking about a carbon take-back obligation?
Yeah, thank you. Yeah, thanks for that. The Net Zero Industry Act in the European Union, very interestingly, has introduced for the first time the notion of an obligation on producers to provide storage capacity. So they've introduced, based on carbon fossil fuel production or oil and gas production specifically, over the past few years, they're obliging countries to oblige companies to provide carbon dioxide storage capacity. It's great that it's opened the principle of an obligation. So on that, I'm 100% behind this. It's opened the conversation of, yes, the industry needs to be part of the solution. We can't just sort of keep buying their stuff and expect other people to sort it out. There are many things I don't like about it. In particular, it's only providing capacity. So if somebody digs a hole and say, look, I've got capacity to put CO2 down this, but nobody's giving me any CO2. So that's the way it goes. It's not clear what happens in that situation. So, it's only 50 million tons. It's kind of a piddling amount. So it's opened the prospect of requiring the industry to do something, which I think is really exciting.
Well, we did have another question about the safety of CO2 storage, which is in our wheelhouse.
That's you.
And we know we've been studying that for 20 years, and we know that it's very safe and secure. But Myles, as always, thank you so much. Can we thank Myles again for coming? Thank you. Brilliant talk. All right.